For APCalculus Notes 8.4, this is video 4, I believe. This table pictured below is a table of values representing an exponential function f of x is e to the x minus 2 minus 3. Use the table of values to answer the following questions. What is the equation of the horizontal asymptote of the function? Explain how you know. Well, the horizontal asymptote is going to describe the end behavior. Looks like if we move to the right, these y values are getting bigger and bigger and bigger. So I would say as we go to the right, the limit is approaching of f of x is approaching infinity. If we go to the left, it looks like these y values are getting closer and closer to maybe -3. I'm going to write that down. The limit as x approaches negative infinity of f of x appears to be approaching -3. The conclusion I can draw from that is this has a horizontal asymptote at y equals -3. Well, that's a guess. It's definitely around -3 because as we go to the left, these numbers are getting smaller, but they're getting smaller at a decreasing rate. So it's either -3 or something super close to that. We're just going to assume it's -3. Is the graph of f of x above or below the horizontal asymptote? Well, we're saying the horizontal asymptote's at -3, and all of these y values are bigger than that. So let's address this for f of x. All the y values are greater than -3. Conclusion we can draw from that, the graph of f of x is above the horizontal asymptote. And that horizontal asymptote is y equals 3. When the inverse function f inverse of x is graphed, will the graph be to the right or to the left? So we're talking about the inverse now. We want to know if it's right or left. Well, for f inverse of x, if for f of x all the y values are bigger than -3, for f inverse, all the x values must be greater than -3, which tells us the graph of f inverse is going to be to the right. Let me copy this and change some things. So the graph of f inverse is going to be to the right of the vertical asymptote of x equals -3. It should be negative for this one above here as well. So once again, if we are above -3, that means in the positive direction. And then in the positive direction for x would be to the right. So above and right are equivalent in these contexts. Just to give reasons for your answer, we put our reasons here at the beginning. What's the equation of the vertical asymptote of f inverse? Explain your reasoning. Well, f of x has a horizontal asymptote at y equals -3. Therefore, f inverse has a vertical asymptote at x equals -3. Identify the domain and range of f of x and f inverse. I'll do each of these. If I can find one, finding the other is going to be super easy. The domain of every exponential function is -infinity to infinity, which means the range of the inverse is -infinity to infinity. The range for f, we said that there was a horizontal boundary at -3, and we said the graph was above it. So that means we're going to be going from -3 to infinity. which means the domain for the inverse is going to go from -3 to infinity. E, find the equation of the inverse of f inverse. Show your work. So if I take the function that I was given, which is right here, and if I interchange x and y, and if I get the base and exponent isolated, this is in exponential form. I want to change this to log form. Log form would be log base e, which is common log, of the argument x plus 3 equals the exponent of y minus 2. If I add 2 to both sides, I'm going to get 2 plus natural log of x plus 3 equals y. And if we want to write it in inverse notation, f inverse is going to be 2 plus natural log of x plus 3. On the grid to the right, sketch this graph. Now, we know that we have a vertical asymptote at -3. That's something that we wrote down earlier. The starting point for an exponential graph is at 0, 1. I'm going to point out some things, and then I'm going to actually not do it this way. But since this is at 0, 1 for the parent, this is translated to the left 3 and up 2. So this point would go left 1, 2, 3, and up 2. That point would end up being right there. That's my starting point. Now, what we would normally do if we had a base that was easily usable, like a base of 2, we would say we're going to the right 1. If we go up 1, we're going to double our distance and go to the right 2. We go up 1, double our distance, go to the right 4, etc. If our base was 4, we would go right 1, and we would go up 1. 1 times 4 is to the right 4. We go up 1 and then to the right 16. The problem with this one is our base is e. So if we multiply this by e, we're going to go up 1 and then 1 times e. E is like 2.7 something. It's a little hard to figure out. Even harder, if you multiply e by e squared is 2.7 something squared. It gets complicated. Here's how we can do this easily. Let's pick out as many ordered pairs as we can from this and just reverse them. For example, here's an easy one. 2, -2 reversed would be -2, 2. We already got that point. Easy peasy. How about 0, -2.865? If we reverse that, that's going to be -2.8650. Obviously, I'm going to be estimating that. It's super close to -3. Not quite there. So I use this point and this point. Let's use this one. -2, -2.982. Reverse it for the inverse. So this is the x value, this is the y value. So if we go to the left even closer to -3 and go down to, maybe we would be someplace close to here. Which, this is making sense. As we go left, we're getting closer to the horizontal, to the vertical asymptote. Another ordered pair that we could pick out that's not too bad. -5 is basically touching -3. I'm using the word basically there loosely. So the original ordered pair was -5, -2.999. We reversed those, so left 2.99 and then down 5. And let's do this one. So reversing the x and y, to the right 4.389 and then up 4. So that would be something like right about here and then up here maybe something like this. A lot of these are being estimated because it didn't turn out well. A lot of these are being estimated because they're not integers, and that's hard for us to graph. This does not become horizontal, but kind of looks like it the way that I drew it. So there it is, it's sketched. There's another example here. I would like you to try this one on your own before you finish watching the next video. Please try this on your own, then watch the video. Just want to make a note here. We use the table. We reverse the x and y values. So one more video for this section, and it's going to have the answers to what we do for the next problem.